Why is the space above our heads so often wasted? Whether you're in a grocery store, a restaurant, retail shop, warehouse, even your own garage, we look up and our ceilings are hardly utilized. Ken Miller, my next guest, he's the CEO of Stackable, started with this very question. And as a mechanical engineer, he turned his curiosity into an elegant solution that's ready to revolutionize how we use the Z space. I'm Ali Afzal, and on this episode of Robot Builders Club, we are getting technical. So fire up your SolidWorks and join us as we dive into Ken's groundbreaking ceiling-based robotic storage system. Let's dive in. Mr. Ken Miller, welcome to the show. Thank you for being on Robot Builders Club. I've been trying to get scheduled with you for some time, and I'm glad this time worked out. How are you feeling?
Oh, feeling well today. Thank you. How are you doing, Ali?
Good. Wonderful. You know, we met at a networking event for roboticists and people within robotics, and I saw your demo for a ceiling-based robotic system. I liked the idea of stacking stuff into the ceiling. It's very unique. I like the concept, the name as well gets the point across. It's very elegant, not just the name, but the solution itself. Walk us through a little bit about the origin story of it and your company, a little bit about your background. You know, most robots that people are familiar with live on the floor, but you decided ceiling was a better real estate. Why? And how did it come about?
Okay, yeah. Well, I was thinking about humanoid robots actually, and what it takes to do a task. And if you think about it, what all that's needed really is two arms and a set of eyeballs. Or in a robotics case, it would be a camera system. And then I started thinking about other ways to move those arms and eyeballs around in the space, without being on the floor, because there's just so much stuff on the floor. There's all kinds of furniture and pets and people and things. And so I just tried to think about a way to do that on the ceiling. And so I started to think about different ways, and I came up with this grid system where I could drive a robot in XY direction on the ceiling and then have a platform that raises and lowers. And I thought if I could attach cameras and robot arms to that, I could fly the arms around in the space, and I wouldn't need all that complication of what's below the armpits in a robot, in a humanoid robot. And so, so I started. That's actually where it started. And then I realized that because the way the ceiling grid was and the way the construction of the robot was, is that we were able to put a big hole basically in the robot, a square hole in the robot. And then between the support rails up in the ceiling, the support rails for the robot, we were able to put another hole and put the space up there for storage. So that's kind of how it all stored.
Got it. My question to you is, was there a single moment or something happened that was sort of like your Eureka moment to go,
Oh
the
yeah.
way we're storing stuff, moving things is fundamentally designed wrong. We're too burdened by the chaos of the floor. We're not looking upwards. Was there something that led to that?
All storage currently is all designed for humans, and a lot of it's really not very well accessible. If you think about the cabinets in your kitchen, the high cabinets, to reach those, you got to get up on the counter, or you got to get a ladder out. And then if there's something at the back of that cabinet, you got to pull all the stuff out that's in front of it to access what's behind. Similarly to the floor cabinets, if you have something that's way in the back of your cabinet that's below the counter, you got to get down on your hands and knees, you got to pull everything out, and you access what's behind it. So even those are going to be very difficult scenarios for a humanoid robot. And most humanoid robots aren't very big, so they have a limited reach. Whereas if the system is based on the ceiling, we can have high ceilings, and we can have storage without the necessity for the overhead cabinets and even a lot of the under counter cabinets.
Got it. And the way you're describing it makes me think that you're thinking of a whole ecosystem of robots in different applications. You're mentioning being able to give humanoid access to materials or inventory.
Mm-hmm.
You're You're thinking Stackable will be a component that fits into a warehousing setting where there's a handoff happening. You're pulling materials from the ceiling that is being stored, and it is going onto a transportation robot of some kind, AMR or humanoid, whatever it may be. Is that the vision?
Well, that's part of it. So initially in a home, the robot can actually deliver items directly to you wherever you are in the space. So you could be sitting on your couch and you could ask for a particular item, and the system knows where it is, in what tray it's in, and it can go and get that tray and it can bring it to you while you're sitting there. So you don't even really have to move. And then it can also interact with humanoid robots. So humanoid robot needs a particular item. It will know, knows what it needs, and it basically the robot would request it, and the system will go and get it and deliver it to the robot. Let's say, in like a pantry situation where if the robot's cooking dinner and it needs some particular item from the pantry, well, the system knows where it is, and it brings it right to the robot. In more of a industrial situation or a fulfillment situation, we're looking at micro fulfillment centers, which are smaller centers, highly localized. And so this system is much better suited for that than a lot of the current systems that use these large bins and take up a lot of floor space.
Yeah.
Or we can actually put systems in stores where it's actually called in-store micro-fulfillment.
Yeah. I mentioned the networking event in San Francisco. I ran into the CEO who I'm going to be speaking to, instock.com. They're in the exact same space, micro fulfillment. They've deployed a system already. It's what you're proposing. The market is validating that. There's instock.com is one player that I'm aware of in the right space. So do you anticipate, if you could have your wish with Stackable, or if you could predict future 5 years from now, what is the biggest application? Is it at home? Is it in micro fulfillment? Where do you see it?
Yeah, that's a good question because there's lots of applications. That's one of the things we've been struggling with is which market to go after first. The home market is probably not quite ready for it. Maybe in a few cases, high-end homes. So we've decided to really focus right now on the micro fulfillment centers. But there's cases in retail, all kinds of retail cases, shoe stores, other cases where we're handing off to delivery robots. A micro fulfillment center, we can hand off our trays from the system directly to a delivery robot, and then that robot can go out into the community and deliver things. Or if somebody has a system in their home or their garage, we can actually bring whatever they ordered. We can bring it right into their system and into their home and bring it right to them. So there's over time this system should evolve to be kind of enabling fully robotic communities actually. And we can also do something we call reverse logistics, where we give things away, where a system that's robotic and automatic can start taking things away, like your recyclables, your trash, things like that.
So in that use case, I'm not understanding the recyclables use case. How do you see Stackable being deployed?
Well, so if you have a sidewalk robot, a delivery robot, right, that's bringing things to your home, we can also then take things away robotically,
Yeah.
automatically.
Got it. And I'm thinking, when I think of returning merchandise, Amazon comes to mind. You're going to Whole Foods or Kohl's or directly to Amazon, depending on what type of return it is. You have to now wait in line. You have to talk to a person. They scan your QR code, and Whole Foods is now dedicating a large part of their grocery store on just Amazon returns, right?
Yep.
You could potentially drop off your package, it gets stored overhead, space that is not being used, right? So your problem statement is, there's so many different problem statements, and
Yep.
your solution, not only it's elegant, but it's timely. So let me go a little bit on I want to understand the origin story, right? Like for others that don't have not spoken to you or don't know you, you've designed multiple products. You spent decades in complex systems, semiconductor fabrication equipment, automation, surgical robots. Where I am, you had a role to play in Johnson Surgical Robotics as well. You've had this whole journey. You're not a new founder. You have battle scars. You've been there. What made you go, I need to start this product. I want to design this product. And more than that, I want to start a company. What is the why? What went through your mind?
That's an interesting question. So I'm just very creative, and I like to build stuff. So I've always had my entire career. I've always had, my hobby is my career. So I've always been designing and building things on the side. I've started a few companies, and some successful, not some so successful. And so when I get an idea, I just start thinking it through, thinking about whether or not it's it could be viable. And I usually then I'll do is maybe write an invention disclosure, file that, see if we can get a patent on that idea. If we get a patent on it, then we might start working on it. And that's kind of been the trajectory of Stackable. I filed for a patent on this like 10 years ago, and got the first patent issued. And then once it was issued, because it's such a broad patent, then I really decided, well, this is really something to pursue. And seeing that the whole robotics revolution is just about to explode,
Yeah.
I thought this would be a really good project to work on.
Got it. Okay, so it's your builder mindset, your curiosity, you're a deep hands-on mechanical engineer, which makes sense because Stackable, looking at the schematics that you have on your website, it looks like something a mechanical engineer that's passionate would put together. How much of it was that curiosity to build something, and how much of it was frustration with existing logistic systems that are out there?
Yeah, actually, a lot of times I don't think about what's out there. I don't do a lot of research. Might try to think of what might be the ultimate system, and then I kind of start noodling on that, and then make some sketches and start to think it through, see if it's possible to even build it. And once we get through that stage, actually we get to the actual detailed design, and go on from there.
What's your process? Curious about that. I work with mechanical engineers, but it's kind of abstract and esoteric for me. Like I always walk by mechanical engineers and they have the SolidWorks or
Yeah.
CAD open, and they're manipulating design. Do you start on paper? Do you jump straight into modeling? Like,
Yeah,
how do you work?
that's a good question. So we used to use a lot of sketches before there was CAD. We do sketches, lots of sketches. So I'm actually pretty good at sketching. But then the CAD came along, and I kind of stopped using sketches now. I'll make what I call a cartoon.
Okay.
First you have to visualize. First you have to think of the idea. Might make a few little sketches, but it has to be visualized in your head first. And then once you visualize it, then you start making what I call cartoons. And that's just kind of simple blocks I'll put in the CAD. Kind of, okay, this could go here, this could go here. This would kind of block things out. Got to get a sense for the size and shape and volume that's available for the different mechanisms. And then start getting into more detail on each mechanism, each subassembly, because typically a complex system is built up of a lot of different little subassemblies. In this robot, we have basically just 4 different subassemblies that do all the work, and each subassembly is actually repeated 4 times in the robot. So we have like 16 subassemblies in the robot that make it function.
Wow. As you were explaining your process of starting with the larger blocks, the cartoon, you use the term, and then you go into details. I don't know why it made me think of Bob Ross, the painter, the personality, and how painting is an analogy. I don't know if you would agree, where you start off with big portions, right? Foreground, background, and you increase fidelity, and design process is similar. There's definitely a parallel between art and engineering. The
Mhm.
processes
Yep. Yeah, and then you get to the point where you get down where you're actually putting in all the hardware, the kind of at the very end. You have all the holes in there, and then you start putting in all the nuts and bolts and screws, washers, every little component's got to be put in.
Hmm.
And that's one thing that's great about CAD these days is you can download all these components, basically from the internet and just throw them into the model.
Yeah, and do 3D print from there?
A lot of times, yeah, we'll make 3D printed prototypes, and I've got some of the stuff from the Stackable system printed, and so we can test it. Sometimes I just build something out of wood. I also have a wooden mock-up, so you just kind of get a feel for the size.
Got it. What's tougher in that whole process? The first prototype, getting to that stage, or actually getting to a system that's integrated and working?
That's another good question. Well, the fun part is designing and building the prototype. Okay, so
Yeah.
I guess you'd call that, and that might be the easy part, but then it gets harder from there because then you got to take it, you got to take those, you got to build multiple versions of that, you got to iterate, you got to, find out all the problems, and keep testing and iterating. And so that's not quite so fun, but it is a part of the process, and I enjoy the whole process.
Yeah, it's that's the interesting part, unique part about product development in the hardware space. You have all of these different challenges, different stages, right? Getting to EVT, something that's validated from a design perspective, having an actual hardware related to that, that's a challenge in its own. And then having an integrated system that requires another set of difficulties and another set of disciplines working together. And then once you have, okay, I've stabilized, I have something that could potentially be scalable, but then mass producing it is another beast.
Yep.
So
Yeah.
you have to
Yeah.
break through.
Yeah, then you've got to
Mhm.
go and basically redesign a lot of it for mass production. Then you're looking at
Yeah,
injection molding, castings, anything to combining parts and as many parts as you can into one part, and just
yeah.
reducing the cost.
DFMing it. Yeah. Okay. No, that's wonderful. Bringing all of that, what we're just talking about, the product development process and your design process, bringing it into Stackable. I can feel your passion for mechanical design, right? It's apparent. Walk the viewers through the system that you have built, like we are mechanical engineers seeing it for the first time. The grids, the cells, the rails, the XY robot, the Z elevator. Walk us through the elegance that looking at it just for the first time people are going to miss.
Okay. Yeah. So there's several different components, as you mentioned. It starts with the cell assembly, and this assembly is designed to attach to uh, the ceiling joists in a standard home where the ceiling joists are on 16-inch centers. And so this is basically made up of four different subassemblies. There's a cell wall assembly, and that looks like that. And there's these latches in here, these purple things, and those latch onto the trays. So there's four of these walls make up a cell. And then the trays, they get latched into the cell. So you can see the latches in there, and then
Yeah.
the tray has these notches on the outside that these latches can latch onto and hold the tray. And then the trays are designed to stack up, so we can singulate and select a particular tray in a stack.
Why so many
Okay.
notches when there's only spring is only getting attached on one particular area?
So, well, just kind of look for symmetry and to make it. I mean, in the vertical direction, so that
Yeah.
we can latch in different locations.
Okay.
So the trays can be anywhere from 25 millimeters, which is basically 1 inch, in 1 inch
Mhm.
increments, up to however much space you have up in the ceiling. So the tray could be 4 feet tall. So this particular tray I'm showing is 75 millimeters tall, is 3 inches tall. That gives you an idea of the size of this.
Got it.
And then the next component is the robot itself. You can see a cell that's attached to what I show here, two ceiling joists. But if you put another cell adjacent to this cell, let's say over here, you can see these cell walls here. So these might be on the outside of a grid, but you can see there's a slot there. And that slot, through that slot goes a post basically that holds little trolleys that support the robot. So the robot runs on these surfaces, okay, inside tunnels created by adjacent cells. And on the edges, you can see there's the tunnel right there. Yeah. And that's where the trolley runs. So there's 4 trolleys, one in each corner of the robot. And the way we change directions, which is really the kind of the trick of this whole thing, is that we lift at an intersection, we lift the robot up a little bit, and then we rotate the trolley 90 degrees and we set it back down. So now we can go the other direction, and now we can go that direction. So that's the grid. That's the grid that forms for the robot to drive on, to be supported and drive on. So these are kind of like rails, these surfaces.
Got it.
Those are the tracks that the robot drives on.
The power, where does that come from?
The power to the trolleys is provided through the post that the robot is hanging from. So the motors and everything are down in the robot.
Got it. And it's battery powered?
Yeah, the robot is battery powered. We'll have modules that can do battery swapping. So what we're showing is we have kind of three types of, well, let's talk about 2 types of trays. So this tray that I'm showing is really just a kind of a dumb tray. All it does is store items. It doesn't have to have any power, doesn't have to have any intelligence. Okay, so there's the tray. But if we add contacts, if we add contact points, electrical contacts, now we can, from the cell, we can extend out contacts and we can make electrical contact to the tray. Okay, I have a little circuit board back here. Yeah. Now we can get that power. Now we can have powered trays. Okay. And once we add power to a tray, now we can do all kinds of things with the tray. So we can start offering functionality in the trays, such as appliances. So now you could have a refrigerator or a freezer, all kinds of different appliances,
depending on the use case,
functioning up in the ceiling. We can actually have dispensing trays. So if a tray is on the bottom of a stack, and let's say we had glasses and we had a glass dispensing tray, we could dispense a glass down onto the Z platform, onto another tray that's on the Z platform, which I'll talk about in a second. And then we can take that platform over underneath another dispensing module, and we could fill it with ice cubes. So we could have a little ice maker up in the ceiling. And then we could take that and we could go over under another dispensing module and dispense any sort of beverage, juices or water or whatever we have up in the ceiling. So after the trays and the cells and the robot, the next feature, what's the right word? The next, I guess, functionality is the Z platform. The Z platform goes up and down from the robot, and that's actually what lifts up the stack and lowers the stack of trays.
Very, very well thought out. You can tell there's been a lot of iterations. You've spent a few hours at least on.
Yeah, got thousands and thousands of hours into this. Yeah.
What was the hardest mechanical problem to solve in this system?
That's a good question. Probably the fitting everything into the robot, the packaging, fitting all the mechanisms in. The drive system for the trolleys turned out to be quite complex. I'm actually, since designing the first one, now I've come up with a concept for another one, but I haven't actually started working on that design. So that's been
the movement side of it, designing the trolleys in a way that it doesn't impede movement. We're talking about how there's chaos, there's clutter, there's all of these things, and moving in the Z direction solves for some of that, but it opens up more challenges. What failure modes have you seen that are going to show up overhead?
It's a good question. We're a little concerned about earthquakes, of course. So we haven't done this yet, but we need to put the system into a simulator and simulate earthquakes and make sure that the latches can hold the trays. So I think we're mostly, and then obviously we have this Z platform flying around in the space. So we have to have sensors on that and system that knows where the people are, so we don't so we don't bash into people, or other objects or pets.
Yeah.
So we have to have a safety system, similar to what they have on other robots, on other autonomous robots.
I think the challenge for you becomes that gravity is now part of the equation, and it's going to carry quite a bit of weight. So you have to plan for safety into the design, which you're already considering.
Yep. So this is another one of the sub-assemblies. We call this the Z lift assembly, which is really independent of the Z platform.
Mm-hmm.
So let's see if I can get this to actuate. Sometimes it'll.
Oh, there it goes.
Okay. So what happens is this little plate and this little finger go up in between the slot in the tunnels, and then this finger here, it rotates a little bit. When we pull it down like this, then we can use that to lift the robot up. And the reason we have to lift the robot up a little bit is to get the loads off of the 4 trolleys, off the wheels, so that we can rotate those 90 degrees.
Got it. To change direction.
Exactly, to change directions. And then one of the things that kind of fell out of the whole design, which was just totally lucky, was that when I started thinking about storing the trays up in the ceiling and how to latch them, is that this same finger, it's a robotic finger. I can use that same finger, that little roller, same finger, that roller on that finger is what actuates the latches that hold the trays up in the ceiling.
I see. So it becomes a continuous. You can orchestrate the movement, lowering of it in the same sort of using the same actuator.
Yes, exactly. Using the same actuator for different functions.
Beautiful.
Yeah, so that just kind of fell out. That was just really lucky.
Yeah, sometimes when you spend thousands of hours designing something, you get lucky here and there. Right?
Yep, we definitely got lucky.
Awesome. No, thank you for sharing and getting into the weeds of it. We can switch gears. I think we understand the concept and the mechanical design behind it. Do you believe ceiling robotics will become a category in its own?
Well, there's definitely potential for it. It's an unused, I want to say, resource. If you think about it, throughout the world, there's probably trillions of cubic feet of unused space. If you go into any industrial building and you lift up the ceiling tile and you look up in there, 90% of the space is unused. It's just a cluttered mess of pipes and wires. It's not organized at all. If it was more organized and designed with some thought, with a ceiling-based system and storage system in mind, it could be utilized. And the same thing in homes. Most homes up in the attic, there's nothing. If you have a pitched roof, that's a lot of empty space up there.
Right.
So it's hard to believe that that systems won't be deployed utilizing that space.
And even you talked home and warehouses, but even in our commercial spaces, you go to a restaurant, you look up, it's just pipes running, especially in California, West Coast. We just leave it exposed, right? And per square footage, the prices are going up, and it's something that can be utilized in a productive way. So there's so many use cases. I was looking at Stackable's website. You're talking convenience stores, gas stations, restaurants, retail spaces, manufacturing, reverse logistics, micro fulfillment centers that you were talking about, right?
Yeah, it's really unlimited. And then the whole ecosystem. So we've also got ways to put the trays into another container that we call a delivery container.
Okay.
And so those delivery containers can be put into shipping containers, and they can be shipped back to where they came from, basically. So the number of the amount of packaging can be reduced dramatically by sending the trays back and forth between factory and where they're and where they're used, home or in a small distribution center. So these trays
That's
could
an
come
interesting
pre-packed.
point.
They could come pre-packed from the factory. And another thing that's nice about these trays is that because they're different sizes, they can be optimized or different heights. Now they're about 12 inches by 12 inches square, but the height can be changed. So each tray can be optimized for what it's storing. So if you're storing something small like packs of gum, you only need a very shallow tray. But if you have taller things like cans, beer cans or soda cans, you need a little bit taller tray. Or if you're doing, paper towels or something, you need a even taller tray. So all those trays can be then preloaded at the factory,
Hmm.
put in a delivery container, and then shipped, to the local distribution center, and then distributed from there, all robotically, all into the home or into the
Yeah.
final destinations, and those packages can be sent back all the way back to the factory. So it could end up to be a whole ecosystem where these trays are the packaging.
Right, and you're bringing up an interesting point here. You're talking to standardizing the shipping
Yeah,
unit, right? Like how the shipping container before shipping container, it was very challenging to achieve global scale
yeah,
supply chains.
yeah, yeah.
You're talking about a localized version of that to and fro from warehouse, from fulfillment centers, and that standard unit maybe is being set up right now by the shipping carriers, like how Amazon has a few set of different boxes, the standard size boxes, depending on what you're ordering. That's what you were talking to, that you could have trays that are of different standardized sizes, and they could be, once you have a robotics ecosystems, floor service robots, delivery drones, all of those could hand off packages throughout the supply chain using the same container.
Yep, that's right. So it's similar to how the shipping container revolutionized logistics. It gave a standard size package basically that stuff could be put into and then moved around basically robotically. Right? So this is a smaller. I mean, it's going to evolve into some system is going to evolve into a smaller version of that. Where
Mm,
you have smaller containers. That's why we call it a delivery container. Is kind of our delivery container is analogous to a shipping container, and we have applied for patents on all that. We
yeah.
have now 3 issued patents and about probably a dozen more pending on this whole ecosystem.
Wow. Okay. I didn't understand that piece fully, and I
Yeah,
think that that's
yeah.
really powerful.
Yeah, there's a lot more to it. I have a whole bunch more. I have a whole bunch of animations that aren't on the website that show all these different possibilities.
Do you see Stackable eventually becoming a data and logistics platform more than just a hardware company?
Well, it has to be everything, right? It has to be a an order, basically an order fulfillment system. So you can order something, and you know the system knows where it is, and it'll bring it to you. And basically wherever you are, you could be in a park, you could be, we can. You mentioned drones. We have a way to hand off trays to drones. The drone would basically carry around a small delivery container, and we can load that delivery container because these delivery containers actually get loaded from the bottom. So we can move trays around, deliver trays by almost any means.
Yeah. Now you have my imagination running wild. There's so many different companies that are coming up with different parts of the last mile solution,
Mhm.
distribution, storage, warehousing, and you're talking about potentially integrating all of those distinct pieces.
Yep. Yeah, we're looking for partners, to do the different pieces. Somebody who does drones, another delivery robot, service robots inside of the restaurants or hotels and so forth. So
Hmm.
yeah, so that because it'd be too much for us to do all that. And then
Right.
these other systems already exist. With some slight modifications, they can be adapted to work with a stackable system.
Got it. So you have to start somewhere. Are you thinking you're going to focus on a particular area? to scale?
Yeah. We're looking at micro fulfillment
Okay.
centers, and more particularly in-store micro fulfillment. So Amazon is starting to put micro fulfillment centers in their stores, in the Whole Food stores, so that
Yeah.
they can offer more SKUs, more products, things that aren't normally offered in the store. So they want to keep their branding keep on brand with the things that are actually out on display in the store, but they also want to be able to offer people things, toilet paper and things that are in different items that they might not normally carry in the store, but people would go next door or down the street to pick up.
Yeah. No, very cool. All of it makes sense. Love the use cases, the elegance of the system, and your vision. Let's switch gears a little bit. I do want to pull on some of your experience, your scar tissue that you've built with success and also from failure. I think success is oftentimes boring. Maybe I'm saying that because I haven't found much success myself yet, but I think it's in the failure, in failing and in struggling, that's where you get lessons, right? So I want to
Yeah,
pull on that a little bit. You've done the Far East production, right? Working with contract manufacturers. You've done high
yeah,
volume manufacturing.
yep.
You've gone through many cycles of that brutal prototype to production cycle. Now that manufacturing is taking off in a big way, not just in robotics. I think we're bringing manufacturing back to the United States. What advice would you share with new hardware founders? What mistakes to avoid? What lessons you have learned that people should consider early on in their journey?
Yeah, the devil's in the details. So you can design a system and it might look great. It might look great on paper, but where the engineering comes in is all the fits and making everything fit together properly so that it functions in the intended way. I've seen many projects fail or struggle over and over because the detail and the thought wasn't put in at that design level, and considering all the mechanisms and the tolerances required to make a system work. So that's a lot of work. It takes a lot of thought, and you can't just slap something together and expect it to work.
Right. What about the customer side of things? Design is one thing, getting the understanding of the problem early on, incorporating what the use cases are, what the customer is actually looking for, what they're willing to pay for early on. Do you incorporate that into the design?
That's I don't know if that's really relevant to my experience, so I
Okay,
might have to pass on that question.
got it. So you design for the problem and not necessarily uh, look at what a potential customer might be looking for early on, right?
Well, yeah, well, you always have to think about the use case, right? So is the
Mhm.
customer, is it a factory that they're putting things together, or is it a human that's going to be interacting with this, or what is it? So that has to be obviously taken into consideration from the very beginning.
Yeah. And talking about Stackable, you've obsessed over the details. It's apparent. You've poured lots and lots of hours and days and weeks and months. You've poured not just sweat equity, but you've poured lots of cash into it. That level of personal commitment, does that change how you make decisions?
I think you become extra careful when it's your money, but that's a good way to think about it. Everybody should think about it like that when they're working for a company and designing something, for a company. They should be thinking about, oh, if this was my money, is this the way I would do it? Would I spend this money?
Hmm.
Is this the most efficient way to do it? Is there a better way to do it? Right? You always want to be thinking through those options.
Hmm. Those different dimensions. And let's talk about the leadership side of things. You've led large teams, 50 engineers. What changes when you go from leading a department to leading your own startup?
So I would say the biggest thing is you're wearing all the hats. So that puts a little bit different mindset on it. And especially at the beginning, you don't have a department helping you. With chat, with AI, it's becoming a little bit easier because you can ask for help and get opinions. But doing it all on your own to begin with, you really have to think about what is the most important thing you should be working on at that particular moment. And that's difficult because it's easy to get distracted by the things you want to work on, the more fun things, and the things that are difficult. It's very easy to push those aside and procrastinate and not ever really get to those. And you don't have anybody to hand it off to. You can't say, hey, the things you don't want to do, you can't ask somebody, hey, can you go do this for me?
Your time and energy becomes that more precious. You have a deadline looming, a personal deadline, right? So it's what do you focus on, like you said, first, that becomes that much more important. That makes a lot of sense. But when you in the past, when you've worked with engineers, what do you look for bringing on engineers for something as mechanically ambitious as your product and robotics in general?
Yeah, I'd say experience. Experience is underappreciated these days. A lot of companies think, oh, there's somebody smart, just graduated from college, but with no experience. And so the more complex the system, the more experience you need.
You might be a little biased on that, right? Like you have experience already, so you know the pitfalls and all of that. That's that classic sort of conundrum: youth versus experience.
Yeah.
When is a college graduate an asset to have?
Well, they usually have a lot of energy, which is a good thing. So that, you can give them almost anything and they will take it on and, be very, what's the right word? Enthusiastic
Yeah.
about it and really dig in and get to the bottom of whatever it is they're working on. And because they're learning, right? That's just kind of an exciting thing, right? So you're learning something new and people tend to like that. So
Yeah.
that's one thing that's
Yeah. So if you don't have experience, you gotta be curious, you gotta be tenacious, and
yeah,
that's the value add you can bring. But yeah, no substitute for experience, and hopefully your curiosity will give you the experience you need to grow.
yeah. And then they also bring all the new the new technologies, right? The latest familiarity with all the communications protocols and ways to communicate and things like AI, and so they're typically very versed in all that, which can be very helpful as well.
Yeah. And in terms of designing systems, right?
Mm.
You've done systems for Department of Defense that are meant to run for years. What does that look like for ceiling robotics? What does easy maintenance and longevity look like for ceiling robotics? How do you
Yeah.
design for that?
Yeah, so you want to make the system simple, so anything that's up in the ceiling is going to be hard to access. So, for instance, Stackable doesn't need to have the basic system doesn't need to have any intelligence in the system up in the ceiling. So it doesn't need to have any electronics. It doesn't need anything other than the little spring-loaded latches
Mm,
in the cells. And then the robot is what does all the actuation. It's also you want to make things that are modular so that if something goes wrong with one particular subsystem, it's easy to take out and replace.
that's it.
And then you want to have diagnostic systems. You want to have the system self-diagnose and do predictive failure
Maintenance.
modes. So you can know that, hey, this motor's starting to fail, and you can replace it. You can replace that subsystem then, before the actual point of failure.
Got it. Yeah. Make it serviceable, add modularity so that you can do swaps, you can add life to it, add maintainability. I don't know if that's even
Yeah.
a word.
Yeah,
Yeah.
yeah, and the predictability. It's important to know, and that's fairly straightforward these days because you can measure the current being drawn by a motor, and you can see, and you monitor that, and you can see if it changes over time. If the motor's having to start to struggle to do something, hey, maybe there's something wrong in the mechanism, and starting to seize up, and you can go and then replace that subsystem before it fails.
Yeah, makes sense. What's one design principle you refuse to compromise on, even if it's slowing things down, even if it's adding complexity?
That's a good question. I don't know if I can answer that question.
I think you've touched upon it, like safety, maintenance, modularity.
Yeah. Maybe simplicity. Some people look at a big system and they say, "Oh my God, that thing's so complicated." But if you start to break it down, there's really it's all built up of a lot of little simple little systems. So I'd say the KISS principle. Keep it simple, stupid. Yeah. So I'd say that's probably the best driver. Trying to think of ways to keep the system simple, but
Yeah,
meet all the criteria.
right. If a mechanical engineer that's listening, that's watching, wants to build something bold later in their career, like you have done consistently, what advice would you give them?
Yeah, go for it. Yeah, it's a lot of fun. Um, you know, don't quit your day job. Keep working, pay the bills, and do again, treat it like a hobby. Treat it like a hobby till it's not. Till you can raise money, use other people's money as much as possible, and yeah, go for it. It's a great adventure.
Oh, great advice. You've done it consistently. You've done it multiple times. I think I've learned a lot on the mechanical front and the principles you've shared. If we're approaching time, but before I let you go, thank you for staying over and sharing your wisdom and knowledge so freely. Before we send you off, I've set up this tradition at Robot Builders Club that we end with a lightning round. I throw a few questions really fast at you and get your first reaction. Just say what comes to your mind without thinking too much. And that way we get even more out of you as we let you go. How does that sound?
Okay, go for it.
All right, let's do it. So you go back to 1999. What would you do differently knowing what you know now?
Try to use other people's money.
Yeah. Leverage capital that's out there. De-risk some of the things for you. Yeah. Ceiling or floor, and why?
Well, the ceiling, because there's just too much stuff on the floor. And
comprehensive answer there. Yeah, like it. Simplicity or flexibility?
Simplicity.
Over-engineering or under-specifying?
Over-engineering.
Voice control or autonomy?
Both.
Yeah, why not? Without using the word humanoid, what is one trend in robotics that is overhyped?
That's a good one. I guess delivery robots, because
Exactly.
people still have to interface with them. It's not a very efficient system.
Yeah. If your robot could complain about you, what would it say?
I'm crazy.
What is more important, youth or experience?
Experience.
You're probably biased there a little bit.
Yeah,
But if you have youth, you can get experience, right?
takes time.
Best mechanical design company in the world right now.
I don't know.
What category would you say? I guess robotics would you say robotics has a lot of great mechanical design happening right now as an industry?
Yeah, robotics it's been around a long time. It used to be called automation. Now everything's called robotics, but it's really exploding right now. It's going to be the next 10 to 20 years. It's going to be crazy what's happening.
Yeah, exciting times. Best thing about being a mechanical engineer?
Just the satisfaction of starting with nothing and designing something, getting all the parts made, put the thing together, watching it work. There's just a lot of satisfaction in that whole process and creating something out of nothing.
Yeah, conception to actually manifesting something that's physical, that does a job.
Yeah. It's kind of like it's kind of like art. I think you were talking about that earlier. You have an idea and you create something that didn't exist before. It's really fun. It's very satisfying.
The human expression, right? Yeah. Most challenging thing about being a mechanical engineer?
That's a good question. Let me think.
The biggest hurdle, the biggest problem
Yeah.
that you face in that discipline. You can pass and we can come back to it.
Yeah, let's pass. I can't think of anything right now.
Because nothing is challenging for you. That's you've been in the industry, you have the experience.
I was going to say that, but that might be a little too arrogant.
You're allowed. You can say it. Why not? One thing robots do better than humans.
Oh, well, they do it consistency, right? A robot typically is going to do the same thing over and over, very, very repeatable, very consistent.
Now flip that. One thing that humans do better than robots.
Well, right now, the touch, the sense of touch, nobody's figured out a way to give robots that sense of touch in the feedback.
There's a few companies working on it.
Oh, yeah.
Having fabrics that feed the sensors. And the final question, you've come back from 2050. What did you see? What message do you bring from the future?
Robotics is the future.
Is it a positive future? Is it negative?
Oh, yeah.
Is it a mix?
No, it's going to be great. There's going to be things done that being done automatically that we haven't even imagined yet. So, and the possibilities are really just endless. I mean, I have ideas of what could be done because I know how to build stuff. So I can dream it and create it, and it's going to be fantastic.
Yeah, love your optimism. I think we're living through a pivotal moment in history where all of this different breakthroughs are converging, and it's going to be an interesting time. That's part of the documentation I'm doing too, talking to founders and builders of different robots. No, absolutely. It's been a great pleasure, Ken. Thank you for dedicating the time on this show, sharing your knowledge, your wisdom, your vision. It will be wonderful to see what you do with Stackable and with other products, how you standardize shipping, logistics, warehousing, retail, home, all of these different things.
Yeah, it's a big vision.
No, that's what you gotta have. I love it. It's been an absolute delight. Thank you so much. Let's stay connected, and we'll maybe do an iteration of this conversation where it ends up, and what's the first use case of your system.
Okay, I'd love to. Thanks, Ollie.
Yeah, absolutely. Thanks so much.
Bye.